Okay, welcome to today's episode. I want to show you the simplest way of doing thread. So let's go. If you look at this, you're able to see this is 20 by 2.5. So this is external thread. So we want to look at how can we do thread in SolidWorks. Simplest way of doing thread in SolidWorks. So I'll show you two ways. So let's go to sketch. Do a simple sketch. For our thread. Simple sketch. Kit horizontal. This one for construction. Can dimension this one as 60. Okay. Can take a line from this. Want to make this one symbol part. Example here. Want to make this one simplest so that you can learn many objectives to understand how we can put thread on such. So because we want to use M20 by 2, so for external thread our major diameter can be, that is 20 stroke 2, that's 20 divided by 2, and this 20 divided by 2. I want to put this one groove for the purpose of making my thread to be straight. That is 20 divided by 2 get, that is 10. Then here I can make this one to be 8. Show you the reason why. This one I can put it to be, this one is length. I can put this one to be 4, and then from here up to here I can put this one to be 13. It's a bit higher. Then this one, let me put it be even 16. It's okay. Because let me put this one 18. This for the purpose of the demonstration. I want to show you how to put thread on this very fast. And this one I can put it as maybe 28, for example. Then we can put, for the purpose of thread, we can put a chamfer of 2 by 45 here. Put a chamfer. Also, to make sure that this is strong, I can put a fillet here, this region. Then a small chamfer of 0.5. Angle distance, a chamfer of 0.5 for sharp areas. Can put a chamfer of 1 by 45 here, like this. Then can come here, revolve, say yes, so that it accepts. So you have this. I'm gonna apply material first away. So I want to look at how can we put thread on this using alloy steel. Then we may save our part as M20 by 2. So this is external thread. Okay, we save the part. We have this. So first way of putting thread on in SolidWorks, once you have your design, ensure for external thread, because I want to use M20 by 2, which means it's metric thread, the major diameter is 20 and I have a pitch of 2, so I'm having a diameter of 20 here. So I can come to features, then you go to hole wizard, say thread, then accept here. Okay, once accept here, the place of putting a thread, now put this one, take this circle as the place of putting a thread. You come to this one where the thread is starting from, click on this part, then click here offset, so that it comes. If I press this one, control 1, if I click this one, it starts from this point, because I want my thread to start far away by 2, So I can offset this one and then 2 mm. It's just away, but remember it's going inside, so I can do offset. It comes away, start from away, then I can change here this one to 28. It goes here 28. For external thread, you have inch die, inch tap, metric die, metric tap. So if you're using bottle, for the bottle you use SP4, but for normal one, I want to use die which means external. If you're using internal, you use tap. So let's go to metric die. Then here it has detected that the major diameter is 20, and here it is putting a pitch of 2.5, but we are not using 20. So what we do is we come here, go to 20 by 2, then it will update itself here. So you see it has updated. This is the major diameter and this is the pitch. Then you ensure that the thread method is cut thread. So we want to cut, not extruding. We want to cut the thread. Okay. Then you have the type of thread is right angle and then left angle. So we're using right angle thread. You can also put the angle rotation for the thread, but here there's no need for this one. You can say maybe shaded. You see, you can put it to be shaded. You can put it to be wireframe, so that you're able to view what is how it will be cut on that part. Then you can also maintain the length in case you want. Once you are satisfied with that, you click OK. This one will give you the thread. You see, this is the thread for external. This is the thread for external. I had put a distance far away. If you see here, this is the starting point. I put it far away so that you can create this thread. Then also, the tip is to ensure that you have a chamfer when you're starting the thread. This is a recess, or we call it undercut, so that it ensures when you're locking, it doesn't exit this section, and also for the purpose of safety. When you're doing a thread, it will not be a point of weakness. Okay, so that is what we have done for external thread. Now let's go to internal thread. The same pitch. Let's see how can we do for internal thread. Same pitch. Then we can do an assembly for this. So front plane sketch. We are using M20x2. So let me put it simplest method on how to put this. Simplest method. So this one, can put this one to be maybe even 30. So I don't want to go too much. 30. I want to show you this. Okay. So for internal will be so you need to do symbol calculations for you to understand how to put internal thread. Symbol calculations. So this is my hole. I want to do a revolve. So I have a 20x2, which means my pitch is 2 and my major diameter is 20. For external, we're using a major diameter of 20. For internal, I will use the minor diameter as 20 minus 2. 20 minus 2. But remember, I'm doing it revolving, so I'll divide by 2 again. Okay. So you take the major diameter minus the pitch. So this is what we obtain for our internal. So I want to put it the simplest. I want to put it simplest, maybe for the sake. For the sake, I want to put it simplest from here. Sorry, this point mouse was jumping, so I need to merge this so that it doesn't have openings. Okay, then smart dimension from this point up this point, so the center I want to put even 13. You see 13, yes, that it has 13. Okay, can put this one to be 16. I want to put too much, then this one I can put it to be 18. Then can do a revolve, fillet of 2 for preventing, fillet of 1. I want to put the inner side, this one inner side, then a chamfer of, let me put a chamfer of 2, this one, chamfer of 1. Can undo because this one I'm seeing it too big for my case. When you put a chunk of 1, the purpose of demonstration, can put a chunk of 1, those areas to ensure that it's not too sharp. Okay, same way to this. Okay, sorry, it's a chunk of 1, same way to this point. Okay, come here, revolve, so that you can give me the whole part. So you have this. So if I do measure, you will find that this one may be, that is 20, may be 18. That is diameter 18. So, which means for our internal, because we are using M20 by 2 for internal, should be less by the 2, each of 2. So we can also apply material, same material. I want to use same material for the purpose of assembly. You can also put a different color here. You can also put a different color for the purpose of assembly. Okay, you can put a different color like this. Okay, then you can put this one as M20 by 2. Let me say internal. This is internal. Okay, and then you can come here, features, thread. Okay, just thread. Accept. To test you this, accept. Okay, then pick this one, inner one, where we're going to start our thread. Here, click here this space, then change this one. If I'm able to see from this side, I can offset again so that you can start our way, then change this one direction. Can even put 1. Yeah, then here I can say maybe up to selection, or can put even 29, for example, 29. Then you put 31. I want to, yeah, this one, that one, at least for far away, then it goes bypass. Then here, for external, we put metric die. So internal, we put metric tab. So we change to metric tab. And then the pitch remains the same. Why did I put 18? Because that is when you're adding, when you are making the pitch for internal and external to match. So internal, normally you take the major diameter minus the pitch. That's why you put it 18. That's why here you see it is 18, then the pitch is 2. Then also we want to cut the thread. Somehow, if you are using extrude the thread, which means this one should be 18. Sorry, this one should be 20. We are doing extrude thread, but if you're using cut thread, this one should be 18. Then here same, so and then click OK. So if I click this section view, I'm able to see my thread inside, how the thread will look like. So this is the thread, you see the pitch. So this is what we have obtained for our internal. Okay, then let's do a simple assembly for the part of, we see how the thread will fit, if the thread will fit well or not. So I can take my first M20 external, then start external, put it here. I want to float this one, float this, so that here I can move it anywhere. Then come to this mate. We're doing now assembly for the thread. We want to see if it will fit or not. Come here, expand this. So front plane and front plane of this, let them match. Top plane and top plane of this, let them match. Right plane and right plane of this, let them match or mate. Okay. Then I can insert the internal one. So this is the internal one. This section I'll put the knurling. So I can come here, maybe rotate this part, rotate this part like this. So we can use simplest way of mating this. Maybe for example, I can say this. There's 2 ways I can mate. You can click here, mate. Then you can come to for mate. You can come to mechanical. Then you say screw. under the screw, maybe, for example, I can expand here. I can take this region. I want this region to mate with which region. I can go inside maybe this region, this, or I can pick this region if I want. So this one will be made, and then how many revolutions do I want? For example, you can put the revolutions, let's say like 10 of them. How many do I have? I can put maybe 20, for example. Okay, then I can ensure that this one I made with um, this one I made. I can do mate with this first of all. Yes, so I can this one. Why is it declining this? Because of this screw, it is not aligning that one. So what do I do? I can first of all do mate concentric with this face, for example. Say okay, then come to mechanical. Or what I can do, simplest way I can drag this somewhere like this. If I was to lock, it will come up to this section, for example. Then I can do a section view. First of all, we want to see how the thread looks like inside when it's mating. So if you rotate this one, you see it will be moving. It will be looking at this until this stage, looking up to this stage. And if we're able to calculate the distance, maybe edit measure, for example, can measure the distance. I want to know how much. Can just drag this one behind. How much to lock in the gap. So I can measure this region to just understand the gap between this 32. So what do I do? I can come here, open this, I want it to fit. Then can come to my revolve this, edit. Once I edit, I can put this one like let's say 32. Yes, 32. Exit this. Can come to even the thread also. Can update the thread. Remember thread I put was at 1, so this is okay. Can also put this one for the purpose of updating my thread. I can put this one 32 because I had put 31. Okay. I say rebuild here. Can close this. If I come here, can do this. So this is the part. So I wanted to, in case for example I was to make this in real sense, then for this in real sense, if you have the part itself, this is how it will be meeting. So it will meet up to that region when you are closing it. So the gap is okay. It's in this side. Let me choose this color. Okay. So if you are mating, you see the pitch. You can see now the internal pitch. This is the internal. This is the external thread. This is internal thread. If you are looking it, you see the gap here. It will be too okay. It has a small gap. That is called clearance from the addendum and the addendum. So this is the thread is okay. It's perfect for this case. I can as well maybe adjust it somehow. Then use let me check now for mechanical thread for the screw. If it will fit in that, then I can come to screw. I can pick. Let me pick this one. Then I can also pick this, like this maybe. Then we just want to do maybe 3 revolutions and say okay. Now you see there's no error because whatever I've done, if I rotate this, Control 7, so you see this one is now locking. How many revolutions? So I have put very few revolutions, or you can change this revolution so that when you're screwing it, it can go inside it. So I can change, for example, this. I can put distance and revolution. Maybe I want a distance of let's say 10 millimeter. Yes. Okay. Then if I'm rotating this, you see, it will go. This is now screwing. I'm screwing it. I'm locking it. This is anti-clockwise. This is clockwise. So I'm using the right thread. So right thread, which means if you are tightening, you're tightening clockwise. If you are loosening it, you go anti-clockwise. So this is what it will happen for my case. So I can also put a linear so that when it goes, it cannot go further into that. So I can come here, mate. Then I put a limit. Let me put a limit. Can come to advanced, put a limit. For example, I want a limit of 0. So then here maybe, for example, let me put it 10 distance from this face. I want to put a limit to this face. You see? Then I can click OK. So if I'm able to rotate this to, if I do this now, I want to open it. This is opening. This is opening. This is opening. It will go up to 10. If I come here, edit the limit distance, you will see that there is a distance of 10 here. It has moved. So if this is a distance of 10, so in case I want to maybe increase, I can as well increase this maybe to, let's say, at this 20. Okay. Then I can update here. Then if I go against opening, you see, it will also increase the distance. You see, it is increase the distance when I'm opening. I can come again here. I can check the gap. So this gap is 20. So it may go up to 20 limit. So I've done concentric mate, I've done screw mate, and I've done limit mate. So that when I'm locking and unlocking, or tightening and loosening my, this is now tightening, it reaches the limit. This is now loosening. If I go this opposite direction, it's the loosening. You see how it behaves. So this is loosening, it opens. This is closing. This is loosening. This is closing. So this is how we are able to design our thread. You see, this is how we're able to design our. This is external thread. This is internal thread. That is how we're able to design our simple thread. Then we do a simple assembly. Then in case I want to check how they are meshing, I'm able to see that for external thread, the pitch and internal thread, the pitch are the same. But for external thread, my major diameter was 20. For internal thread, my minor diameter was 18, and the major diameter would go up to 20. So if you guess to see this, which means at this region, this is where now our 20 will become. But here, at this region, this is where our 18 diameter will become for internal thread. For external thread, if you check this region here is where our 20 diameter is, and here is where our 18 diameter is. So it is opposite of each other. So this is how we're able to design our thread in SolidWorks. Simplest way of designing thread. It's not instead of creating those sketches, but take care of how or where you start from. If I do maybe let's say top transparency, I'm able to see inside how the thread looks like. You see this now, how my thread looks like. If I'm closing, you see opening and also closing, how they behave. So this is what we have learned today, how to create a simple thread, how to for internal and external using M20x2, that is metric.